Now, you will have friends that are not fancy and that will, when they see this much math, like go, ah! So if you want to be friends with them still, you can do bad clustering. We did awesome clustering. We used an explicit model. We explicitly tried to optimize it. We learned that, okay, we might hit a local optimum. How do you get around local optima? Well, maybe you seed with those 500 different random models and pick the best one or whatever. But at least we have an explicit optimization criterion that we're dealing with. In the real world, people do something stupid called agglomerative clustering. And I just want to make sure you've heard about it before you go out into the mean, awful world. Agglomerative clustering is the world's worst algorithm, and it goes like this. Let's see. Pick the 2 points that are closest. Put them in the same cluster. Make a cluster centroid in the middle of your points. Repeat. Pick the 2 points that are closest. I don't know. Make a new point, make a new pretend dummy point in the middle of those. Repeat. Pick the 2 points that are closest. Well, it's probably these two. Make a new, now you have 3 points in this cluster. Now, so you make a point in the centroid. Now pick the 2 points that are closest. I don't know, is it these two are closest now? No, it's probably these two. Well, then you probably get these two, and then you probably get, I don't know, those two. Or anyway, that's you build up the cluster as you go. To find the 2 closest points in a set of n points, what's the computational complexity of this class? N squared. Yeah, if you've got 1 million data points, do you want to be doing an n squared calculation? No. So life sucks if you're trying to do stupid clustering. That's why it's stupid. Now, one nice thing that you get out of this, though, is because you're adding things one at a time, you can build beautiful pictures. So if you have all of your, if let's say each data point corresponds to an animal species that you're doing clustering based on their genome similarity, you can have like species 1, species 2, species 3, species 4, species 5, and then you put distance on the y-axis, and things that are very close together are joined very low down. So let's say 1 and 2 are very close. And 3 and 4 are not quite as close. So they get joined at a slightly larger distance. And then eventually the cluster centroids of this cluster and this cluster are eventually joined together there. And then that creates a new centroid, which is eventually joins up with 5 here. Okay? So you get these beautiful pictures. This is called a dendrogram. And that's what you get when you do agglomerative clustering. And it's very pretty and looks nice. And biologists love this kind of stuff. So, I don't know. If you need to make a dendrogram, maybe you need to do agglomerative clustering. There are approximate ways of getting nearest neighbors, especially in high-dimensional spaces. So just be aware of that. You might want to look something up. I had a guy take this class, and then like 3 years later, he sent me an email out of the blue saying, well, I'm glad I took your class because you spent 15 minutes talking about agglomerative clustering, and I just used it in my job, and I think he did this silly way, not EM. But so that's why I'm still doing it in my class, because someone said it was actually useful once.
Is it silly because it's inefficient, or does it produce bad results too?
So the reason I hate it is for 2 reasons. One, it's inefficient, and another is it's completely unprincipled. When you get this result, is this optimal? Like, I don't even know what metric is being optimized here. Like, we're fitting a model to the data. The model has something to do with trees, I think. But how do I judge the goodness of fit of this model to this data? Like, it's not very principled. I defined it in terms of an operational procedure. I am much more comfortable when you can write down what we're supposed to optimize, and then we can try and optimize it and find the best answer according to the criterion. I don't even know what the criterion is here. I just make pretty pictures.
And other people people don't know either.
Right. Yeah, exactly. So there's been some work in trying to justify methods like this and find out, well, what are they optimizing? But yeah, I think you're basically just hosed.